Hey, hello everybody. How's everybody doing today? I hope everybody is having a very wonderful evening. It's good to hear from everyone here. We're here for another Math 102 rip-roaring excitement of a class. At least I hope so anyway. We're gonna get started here in just a few minutes. Hopefully I'm gonna get another section in here today. Shouldn't be too long, I promise you. Hopefully we'll get a few more people in here and we'll get going. See this. Okay. That. This. Do this. There we go. Probably work. Take a good look here.
There's a distance between us. It's getting hard to reach out. Haven't seen you in seasons, but all I hear is your voice. I know my limits. You can break me down.
Alright, we'll get started here in just a few seconds. Or just another minute, and then we'll get going here. Let's see Sammy. I see Sammy and Bill in here, so it's good. I hope you, Sammy and Bill are doing well. Hope everybody else is doing well this fine evening. And we'll get going here in just a minute. Alright. That should probably work, I think. Sometimes my computer setup requires more tweaking. All right, let's go ahead and get started here for today. Let's do some intros. Let's get going, and let's knock out this next section here. Let's do it. Okay, let's get started today. Welcome back to Thursday, end of the week time today. So today, everybody, today we are going to be moving on here within Chapter 10. We're going to be doing Section 10.2. We're going to pick up where we left off last time. Last section here in Section 10.1, we talked about the basics here about hypothesis testing. And so today we're going to be, again, using that same stuff that we discussed here previously on Tuesday, and we're going to be applying it to this step-by-step process here. As I mentioned here last time we did talk about the first couple of steps, again, identifying some important key pieces and doing hypothesis testing. Now we're going to be applying that to an overall problem here in a given context. All right, so let's go to the big board here, and let's see exactly what we're working with. All right, I want to give you a friendly reminder here from last time. So let's talk about what we did here last time. So really quick, we talked about a null and alternative hypothesis. We said H0. We said that was the baseline or base case, talking about a null hypothesis here. Of course, we had a claim here, which is the alternate hypothesis, which is H1. Okay, and again, with the alternate hypothesis, remember that we could have one of three possibilities. We could have, again, a left tail, a right tail, or a two-tail case here. So again, a left tail here is saying if it's less than, a right tail here being a bigger than, and a two-tail being not equal to, right, respectively there. All right, and as you know here, we're going to be making one of two possible final answers here, which we'll discuss here at the end of the problems that we're going to be doing here today. And we also are going to incorporate here today the significance level, okay? So that thing that we talked about here last time, we didn't really do much with it, but today it's definitely going to be applicable into what we're going to be doing. So, in what context are we actually doing this type of hypothesis testing? Let's take a good look here at question 8, and let's see exactly what we're working with. Okay, so in this context here, we're going to be dealing with population proportions. Now remember, for population proportions, this had stuff to do with, like, for example, just asking a survey question. For example, do you like brand A? And we would mark down how many people like brand A, and how many people we asked overall, for example. All right, so let's look at question 8 here. What assumptions must we make to do a hypothesis test for a population proportion? Okay, so if we're going to be able to do a hypothesis test with just like a survey question, we have to follow certain rules in order to do so. That way we qualify, all right, for doing a hypothesis test here. Sorry, turn that down a smidge. All right, so let's look at letter A. Letter A says is that we have to use a simple random sample of or data from a randomized experiment. So again, each person in the sample or each item in the sample has to have an equal likely chance of being selected as part of our study. All right, so that's letter A. Again, it has to be completely random by chance. All right, so that's pretty much how that works. Letter B, we have to pick a sufficient large enough sample size. So a sufficient large enough sample size here, again, we have to follow NP times 1 minus P has to be bigger than or equal to 10. All right, so that has to be definitely true. All right, and then finally, every sample, every member of the sample, again, every person or item has to be independent of each other. Okay, so again, one person cannot, for example, cannot influence another person's opinion on the matter. Okay, so again, you can't have one person influence the other. They must be independent in nature. Okay, so let's talk about what we're going to be doing here today. We're going to discuss here how do we perform a hypothesis test using the p-value method for a population proportion. Okay, so we're going to look at a couple of examples here today, and first and foremost, we're going to go over the first 3 steps here, which are pretty much the same kind of 3 steps or 3 steps that we discussed here last time. So we're step 1 here. Again, we're going to determine the null and alternative hypothesis. Now, the null and alternate hypothesis here, I want you to take a look at the context that we're going to define it in these cases. First of all, what's the null hypothesis here? The null hypothesis is going to use P, which is going to equal the population proportion. So the population proportion will be given to you in the problem somewhere, and you're going to need to identify what that is here. And we're going to set that equal to p, again being the notation for a proportion here appropriately. Okay, so we definitely have that. Now, next, we also need to identify the alternate hypothesis here, which is less than, bigger than, or not equal to. Again, less than being less than, bigger than, not equal to, reflecting left tail, right tail, and two tail respectively. So then we indicate that type of test in step number 2. Okay, again, there will be a reason why we do set this apart from other steps. And we also will state the level of significance. Again, this is something that we do not need to find. It will be given to us here also in the problem as well, but will be needed to state it in its own step, again, because it will be referenced here later on in the process. Okay, so it does play a very important role. Again, we just state it as a separate step. Okay, so let's take a look at an example and do these first 3 steps here first and foremost. Okay, let's look at an example. There we go. All right, so I'm going to kind of shuffle back and forth here, but it's got to be done. All right. So the example that we're going to be doing here, in this case, is going to be number 17. Okay. So let's go ahead and talk about number 17 here, and we'll see exactly how this works. All right. Lipitor. All right, so the drug Lipitor is meant to reduce cholesterol and LDL cholesterol. In clinical trials, 19 out of the 863 patients taking 10 milligrams of Lipitor daily complained of flu-like symptoms. Suppose that it is known that 1.9% of patients taking competing drugs complain of flu-like symptoms. Is there evidence to conclude that more than 1.9% of Lipitor users experience flu-like symptoms as a side effect at the 0.01 level of significance? Okay, let's talk about this here. All right, so let's go over step 1 here. Again, step 1 here is to define our null and alternate hypotheses. So again, let's first follow our null hypothesis here. Now, our null hypothesis, according to the handout here, is going to involve P, which is equal to the population proportion. So taking a look at the problem here for the null hypothesis, what is the population proportion? What is the population proportion equal to here in this problem? 863, not quite strolling. That would be our sample size. 863 is how many people we asked. Hey, Mini Real, how you doing, my buddy? Are you at home? I'm assuming you are. Strolling, you gotta read this carefully here. We're talking about population proportion. So if we're talking about proportion here, alright guys, slow down for just a second. You take a look at this very carefully here. The population proportion discusses the entirety of the whole big picture. Okay? Oh yeah, I'm gonna get mine this weekend, my dude. So let's look at the big picture here. Remember, we're using it as a baseline here, something that we're going to compare against. And remember, a proportion here is always a percentage. So what would our population proportion be according to the problem? Let me make this a bit bigger here. Sorry. Yep. 0.019. So yes, that's correct. 1.9%. But again, we do want to reflect that here as a decimal. So 0.019 is correct. Okay, so do understand. Remember the context that we work in here. It's not just the first number you see. You have to. Happy Friday Eve. Thanks, man. You too. But yes, it's not the first number that you're going to see here in the problem. It's basically going to be, again, what proportion represents. And that represents a percentage here. Again, 0.019, which is 1.9%. Hey, Mini Real, how are you feeling after your third shot there, buddy? I hope you're feeling good. Hopefully it's not gonna wreck you too bad. Yeah, sore arm is pretty normal. I mean, I had a sore arm when I had my second shot. It's just the 12 hours after you get your shot. That's where it really starts to set in. Yeah, that's true. For you, yes. All right. What about our alternate hypothesis here? So here, remember, we have our proportion here of 1.9%. All right. Again, if you take a look here, it says, suppose that it is known that 1.9% of patients complain of flu-like symptoms. Now, for your alternate hypothesis here, remember that we're going to use the same letter, the same number. The only thing we care about is what goes in the middle there. So do we have less than, do we have bigger than, or not equal? Which one is this going to be? Less than, bigger than, or not equal to, according to the problem here for 17. Bill says more than. All right, so strolling. Okay. And that is correct. Very good. It definitely is, or it says more than. That's right. Again, if we read the problem here carefully, again, it does say, is there evidence to conclude that more than 1.9% of Lipitor users experience flu-like symptoms? So, more than is absolutely right. Okay, good. So let's answer this next question here. What type of test do we have? Do we have a left tail, right tail, or two-tail test? Do we have a left tail, right tail, or two-tail test? Let's state that for step number 2. All right, Horitz, Maritza Strolling. I'll say right tail test. Okay. So it is more than. So it is clearly a right tail test. Good. That is correct. All right, good. Now we're also going to do step 3 here. We're going to come back and use right tail test here, most definitely. We'll also state step 3 here. And again, that's just part of the problem, stating the level of significance. So the significance level here we're given is 0.01. Okay, so that's just a random value we're given, and we got to state it here for sure. And this is used as our comparison tool, so we'll use this at the end here, but you'll see how it works. It's not as hard as you think. We'll come back to it. Okay, so before I move forward here, any questions so far? So before I move forward, any questions so far for these first 3 steps? Okay. All right. As long as everybody's okay, that's perfectly fine. We will move forward then. Okay. Let's focus on the last 3 steps here. So the first 3 steps are pretty standard modus operandi kind of steps. Okay, they're going to be our standard MO for these type of questions. Now, the last 3 steps, though, are things where things definitely get a little bit different. Let's talk about the last 3 steps here. And this is stuff we didn't talk about before in the last section. So what is step number 4? Now, step number 4 and step number 5, and then we also have step 6 here. We'll talk about each one of these. That's slightly a bit smaller there. There we go. All right, so step number 4 here is we're going to talk about computing the test statistic, okay? This test statistic here allows us to go ahead and find a particular value that reflects our current data, essentially, and be able to make a proper comparison. In any case, to find this test statistic here, it usually involves a pretty complicated, could be complicated formula here. Again, what you'll see in these two sections, sections 10.2 and 10.3, will reflect again how we can find this test stat here with a given formula. Now, let me point one thing out here. You're not intended to memorize this formula, okay? We're not even intended to, well, okay, we are going to use this formula, but not in the way that you're probably thinking about. Now, let's take a good look here at step 4, at least in terms of the big picture. In terms of the big picture, to solve for this particular test stat, we do need some information here. Now, we already have some of it. For example, we have the notation here, we have P. P is representing the population proportion, which is what we found here in step 1, the 1.9% as a decimal. But we also need a couple of other key pieces of information. For example, we need an X and we need an N, X being the number of yeses and N being the sample size. I will point out one thing though, just to be on the safe side for you guys. You will not see this written, like what's written up here on my handout is not exactly what's written in the book. What's written in the book is like P hat. And honestly speaking, that can be very confusing for most people, so I basically broke it down into one further step, and I put X over N minus P to make it easier to kind of digest and know where numbers need to go in this given circumstance. All right, so we definitely need an X and we definitely need an N. All right, so let's go back to our question here for just a moment. All right, what is X and what is N? What is X equal to? And what is N equal to here in our given problem? All right, so from our survey here, what is X equal to and what is N equal to? So X is equal to 19. Strolling says X equals 19. And N here is equal to 863. All right, so that is correct. Very good. We have 19 people said yes to that question out of the 863 polled. Fair enough. Okay. Now, let's say we take all the values that we have here, the X, the N, and the P, okay, all those guys, and let's plug it into the formula. Say, hey, I want to find the test stat here. All right, and again, you can use this as a nice little check. So, for the sake of this example here, I'm going to just write out the test stat using the formula that we see here off to the left. So the test stat here is going to be, again, 19 over 863 minus our P here, which is 0.019. We'll divide that by the square root over 0.019 times 1 minus 0.019. Divided by 863. It's 6:24 p.m., buddy. I don't go to sleep for another 6 hours. Okay, now let's take a look here at the test stat. Now, taking a look here at the test stat, there is one problem with the test stat, all right, as you can see here on screen. And that is this formula here with all the numbers written in is extremely messy, okay? Very, very messy. It's ugly. It's really ugly. Now, I want you to understand one thing. Please, 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 do not enter this into the calculator. You will have a bad time. All right, it will be ugly, it will not be very nice, and it will be not so great. All right, I do not want anybody to enter this formula here into the calculator. Instead, what we're going to do is we're going to take an alternative approach to actually find this number here. We will find the answer to this test stat here. We'll have the calculator effectively do it for us, okay, in our stead. All right, that's what we're going to find here in step number 5. All right, so here for step 5, is we're going to go ahead and find what the test stat is here. Wow, that's a very light color. Let's go with this dark red. Sure. All right. Okay, so let's go to step 5 here, and we're going to figure out what the test stat is, and we'll also figure out the p-value here. Remember, this is a p-value method, so let's look at step 5 here. It says, use the calculator one prop z-test to determine the p-value. All right, so we're going to use all the given information that we have here, and we're going to now find the p-value along with the test stat here in step number 4. All right. So let's go ahead and use the calculator here. All right, so everybody needs to take out the calculator for this. We're going to do button presses time. All right, it's time to do button presses. All right, so what I would like you guys to do here is please type "got it" in the chat once you have your calculator out in front of you. Please type "got it" in the chat once you have your calculator out in front of you. Make sure everybody's on the same page before we get started here. Sammy's got it. Good. Strolling 2 and Maritza. All right. Bill. Make sure you have your calculator there. Got it. All right. Mini Reel, hopefully you have your calculator there. I'm kidding, I'm kidding. Sanla, there you go. Hello. Got it. Okay, perfect. All right, just make sure everybody's got their calculator there. All right, Horit's got it too. Perfect. Nice. All right. Okay, so everybody that I know here is on chat has got their calculator there. All right. So let's go ahead and do this first here. What we're going to do first here is we're going to go ahead and hit the stat key. Hit the stat key on your calculator here. And we are going to scroll over to tests. Okay, we're going to scroll over to tests. Then I would like you to scroll down to number 5. Number 5 that says one prop z test. I'll put that in the chat here. We have one prop z test. All right, number 5. And go ahead and hit enter. Okay. I'm trying to find my calculator. It's all good, buddy. All right. So, let's talk about what we see here on the screen. All right. What we see here on the screen is we need to enter in a few values. First things first here is this P0. This P0 is effectively our population proportion. We do need this number here. So that's the P that we identified here for our null hypothesis. So we're going to put 0.019 here for our null hypothesis to make that representation. Okay. All right. Next, we have the two values we absolutely need, which is going to be our x and n. So our x is 19. And our n here is 863. And now comes probably the one of the more important parts here, and why I would like you to do step 2 as a separate step. In step number 2, we identified the type of test as a right tail test. And this is very important because of this part right here in the calculator. You need to tell the calculator what type of test that you're doing. And the calculator has it written in a particular order. As you can see here, it's not equal to P0, less than P0, bigger than P0. Essentially, in order, it says, all right, you have the first one here is an option for a two-tail test. The next is a left-tail test option. And the third is right-tail test. So it goes two-tail, left-tail, and then right-tail. So obviously, in this case, we have a right-tail test. So we're going to highlight that last one there and hit enter. Then we'll go down to calculate and go ahead and hit enter on that once you're good to go. All right, so we're gonna get these numbers here that you see here on the screen. Now, if you got these same exact numbers here as I have on my screen on your calculator, please type "got it" in the chat. Make sure everybody's on the same page here. Alright, Strolling, Maritza, Sanla, Sammy, and... Hortz, and Bill. Okay, all of you got it. Perfect. Okay. Alright, very good, very good. Alright, great job, everybody. So far, so good. Alright, glad you're following along, no problem. Alright, let's take a good look at our results here, and let's see what we can glean from this. Alright, so... taking a look at this here, we have two values that we want to look at, two particular numbers. Let's take a look at the first number here. This is z is equal to. This z here is the same notation that we talked about for the test stat, so that's what this first number represents. This first number here represents the test statistic, okay, or aka the test stat. So this is what we're going to put down here for step 4. If we want to find that test stat here, that's going to be 0.6490. Okay. And here in step 5, the next number below it says p is equal to. That's going to be our p-value here that we need here for step 6. So this p-value here is going to be 0.2582. Okay, so there is our step 4 and step 5. All right, so we found first number here is 0.6490. Second number here, 0.2582 for our p-value. The other two numbers here, of course, the sample size, and this p-hat here represents 19/863. So if you divided those two out, this is what you get for p-hat. But we're going to ignore those two numbers here. The only numbers we care about are these first two numbers we have here, okay, representing the test stat and the p-value. All right. Good stuff. Now, we're done with the calculator at this stage. And now we got to go to step 6, which is our conclusion. So the question is, what are we going to do with the p-value? Let's take a look at what we do with the p-value. And now we're going to incorporate the one part we haven't actually used just yet, which is the significance level. So remember that we could get one of two answers, right? We only get two possible answers in any hypothesis testing problem. So let's see how we can make, what conclusion we can make at the end of the day. So as you can see here, it says if the p-value is less than the level of significance, so that guy here in step 3, okay, so this guy here, this alpha is equal to 0.01, if the p-value is less than that, then we reject the null hypothesis and accept the alternate. Otherwise, we accept the null hypothesis and reject the alternate. Now, the easiest way to kind of remember this is to basically put this, put this in terms of a question, okay? A very simple question. And that question would be, say, for example here, is our p-value 0.2582 less than our level of significance, which is here in step 3, that's why we refer to it here, is 0.2582 less than 0.01? So it's a yes or no question for all of you here. Is 0.2582 less than 0.01? Okay, so the answer to this is definitely no, okay? It is not. So, if this answer is no, and all of you are correct, the answer is indeed no. If this is not less than 0.01, the answer is no. Which conclusion are we going to make here? Are we going to reject the null and accept the alternate, or accept the null and reject the alternate? Which one of those two conclusions are we going to make here? What is our conclusion? Reject the null and accept the alternate? Alright, let's put a poll here. Why not? I'll screw around for a little bit. All right, so put a poll here. There we go. Oh. How does this not meet guidelines? What guidelines are you referring to? I have 2 responses. Alright. I don't know why this won't allow me to do a poll, but for some reason, it doesn't like that. Alright. Let's see if that works. Actually, kind of curious now. Oh. I guess I can't do that. Alright. I made a mistake. Accept the null and reject the alternate. Alright, you weren't sure. Well, let's take a look here. Take a look carefully. Read that step 6. It says, if the p-value is less than the level of significance, we reject the null, accept the alternate. Otherwise, we accept the null and reject the alternate. So it comes basically strolling it. Yeah, it comes down to a yes or no question. If I say, if this is true, I can think of it as a computer science program. It says, if this is true, I would fall underneath that first category. If it's not, I fall underneath the second category. That's how it basically works. Right? So so everybody, which one of those 2 answers is going to be our answer here? I'm just gonna put this C in this works. Alright, that doesn't work. Alright, that's weird. Accept H0. Alright, so let's put the whole conclusion down, Horitz. The whole conclusion. I want, see, either... Alright, guys, you guys gotta help me out here. Because you guys gotta tell me which one it is. I see a mess of answers. I see both answers, and I need a firm, solid lock on one of them. Give me the full one here. Accept the null and reject the alternate. Okay, is that everybody's final answer? Okay, that's my final answer. Sammy's like, yep. Alright, let's put down the final answer. The final answer is indeed, we are going to accept the null hypothesis and reject the alternate. This is true. That is correct. Remember to write out that whole conclusion here. Again, the reason why I say to write out the whole conclusion is because of the fact that the homework questions will also state the full conclusion. So you just need to be on the lookout for that as well. So again, it is a yes or no question. You just got to answer yes or no. Again, if it's yes, it's the first case. If it's no, it's the second case. Okay. All right. Any questions about that example? Any questions so far, guys? Nope. All right. Let's go ahead and try another example then. which one, Sanla? Do you want me to scroll up on? I'm not sure which one you want me to scroll up on. You want me to scroll up on the handout or the, oh, the handout, okay. You mean here? On that first page there? Is it the first page or is it question number, or is it step 4? Which one do you want me to look at here? I'm a little confused. Are you good? Okay. Alright. Okay, let's look at the next example then here. Okay, so the next example we're going to do here is we're going to do number 21. Let's do 21 here together. Alright, we'll go through the steps here, same as before. Let's see if you guys can start putting these pieces together. You guys will know how the pattern goes. Pretty simple, hopefully. Alright, let's read this here together. Number 21, taught enough math. Alright, in 1994, 52% of parents with children in high school felt it was a serious problem that high school students were not being taught enough math and science. A recent survey found that 256 of 800 parents with children in high school felt it was a serious problem that high school students were not being taught enough math and science. Do parents feel differently today than they did in 1994? Use the 0.05 level of significance. All right, let's go ahead and do these steps out here. All right, step 1 here, we gotta do the null hypothesis here. What is the null hypothesis here in this case? What is P going to equal here? What is the null hypothesis here? Oh. Maritza says 0.52. Trolling says 0.52. I will tell you that it is definitely 0.52. Very good. Nicely done. So we'll put that down. Alright, good. 52%. That's our baseline here that we're working with. Very nice. Alright, so far so bueno. Alright, what about the alternate hypothesis here? What is the alternate hypothesis here? Again, we're going to use the same letter and same number. What's the alternate hypothesis? We have less than, bigger than, or not equal to. Less than, bigger than, or not equal to. Okay, Strolling says not equal to. Let's see if other answers here. Rita also says not equal. Okay. So, in this case here, taking a look here, the correct answer is indeed not equals to. That's right, Bill. Absolutely right. Again, the dead giveaway here for not equals is the last line here. It says, do parents feel differently today than they did in 1994? So they don't say less than or bigger than 52%, but they say, do you feel differently? So not equal to 52%. Essentially what they're after here in this case. All right, let's look at step 2 here. What type of test do we have here? Do we have a left tail, right tail, or two-tail test? What type of test do we have here? Left, right, or two-tail? Sorry, I just need to get a little drink of tea. Alright, so Strolling, Maritza, and Sanla all say a two-tail test. And that definitely is correct, okay? This is definitely a two-tail test. Alright, very good. So it is a two-tail test. All right. And then finally here in step 3, at least on the halfway point, we're given an alpha here. We have 0.05. So, all right, fine. That's what we got here. Easy enough. That's our significance level. Okay. Let's go to step number 5. Oh, step 4. Oh, sorry, not step 5. We'll do step 5 along with step 4. But we're going to need some information, of course. In step 4, we need to find our test stat here. So let's go ahead and mark down the information that we need here. We need x and we need n. Okay, so we need to figure out what both of those are. Let's go back to the problem here. Okay, so what is our x and what is our n? What is x equal to? What is n equal to? So x here equals 256 and n here equals 800. Okay, that's right. Very nice. Okay, so far so good. Now again, you don't have to write out the formula for the test stat, but if you did, alright, and if you said, hey, I want to check it for myself, then you can certainly write out the formula. Again, do I recommend you to do this for every single one? No, but again, some people want to check just in case sort of deal. So I'm like, yeah, that's fair. So we have, again, using the formula here from the handout. Okay, this formula here. 256 over 800 minus 0.52 divided by the square root of 0.52 times 1 minus 0.52, and we divide that by 800. Alright, so that would be if we wanted to write it all out. That's fine. I know that seems a little silly, but again, some people like to have the numbers in front of them, so I'd do it for them. Alright, now we're going to put this in the calculator, of course, to find our p-value and our respective test stat. So let's find out what that is. Let's bust out our calculator again. Let's see what we get here. Well, let's hit the stat key. Let's go over to tests. We'll go to, again, number 5 here, which is one prop z-test, and hit enter. Okay. Let's enter in our p-value here. Our p-value here is, again, given to us as 0.52 from our initial outset. So we have x here, which was 256, and n, which was 800. Now remember, the type of test we were given here is a two-tail test. Okay, so because this is a two-tail test, we're going to select that very first option we see here on this line for not equals to. Go ahead and hit enter there. Okay. And let's go ahead and go down to calculate and hit enter. Okay. Now really quick here, I would like everyone to type "got it" in the chat if you got these same exact numbers on your calculator that I do here. These are the intended answers here, by the way, so don't freak out. That's exactly what it should be. So I want to make sure that you got the same numbers, though. Hopefully everybody's okay. Strolling Horrid, Sammy, Maritza, okay. Let's see about Sanla and Bill. Hopefully you guys are okay. You got that. All right, Bill got it. See if Sanla got it on their calculator there. Okay, maybe Sana stepped away for a second. That's perfectly fine. All right, let's go over our answers here. All right. So our answers here that we have, in this case, let's use orange. All right, so we have our first value here, which is our test stat. Our test stat here is going to be negative 11.3228. That's going to be our test stat here in this instance. Now, we also have the p-value here. Now, the p-value here is fairly interesting, and admittingly, by the way, this is something that can happen here, okay, at times. This can happen when we get a particular p-value. This is basically, so again, if you're not sure, rewatch this video and remember kind of this particular example. Now, this is basically, the p-value here is 1.0396, and then we have this. Now, the p-value here is not, and I will repeat, is not 1.0396. Do not forget that you have this e to the minus 29, right? Now, what does that little e to the minus 29 represent? Well, remember, when we did normal CDF functions, we did 1e to the 99. That's 1 followed by 99 zeros. In this case, it works the same way. It's scientific notation. All right, only this time you move to the left instead of moving to the right. So we would have, in other words, this would be 1.0396 times 10 to the negative 29th power. Effectively, what you would do is you would move 29 decimal places to the left to actually show that actual number here. So you move 29 decimal places to the left. So you actually have a very, very tiny number. So you basically have 0.28 zeros and then 10396. So as a physical representation, this is what it would look like. This is basically the actual representation of that particular number with that many zeros. So you can tell that, of course, the number is incredibly small. All right, very, very incredibly small. All right, so basically, if you're around to 4 decimal places, it's pretty much a 0, right? So, as you can pretty much tell, because it's so infinitesimally small. All right, so I'm just letting you know, though, the number still exists. It's just really, really tiny. So if you do see this number here, you're making comparisons, make sure you know what that means. Okay, it is important here. All right, so the next part here, of course, is step 6. We're going to take that number. Now let's ask the question here. Take our number here, because we now know what that is. So is 1.0396 times 10 to the minus 29 power, is that less than our significance level? Well, from our problem here, our significance level is 0.05. Okay. So this is a yes or no question here. Is 1.0396 less than 0.05, yes or no? Okay, definitely yes, right? That's a really small number in comparison to a much larger number in 0.05. The answer is yes. So because the answer is yes, what's our conclusion that we can make here? What is our conclusion? What conclusion can we make here in this case? Let me put my emote up. Accept the... Alright, full statement there, Sanla. Full statement. Don't just say part of the statement. Give me the full statement. Alright, thank you very much. Reject the null hypothesis and accept the... Reject the null hypothesis and accept the alternate. Very good. That's correct. Good, good, good. So we're going to reject the null hypothesis and accept the alternate. That's correct. Okay. Very good. Nice job, everyone. Are there any questions? Any questions you guys have? You guys think you got the process down okay? No? You guys pretty good with the process? Hopefully everything's easier now. Now the hypothesis testing isn't as scary as you thought. Good. The homework is pretty much the same. Pretty much. I say pretty much because I know there's some minor alteration. The real question is, Strolling, is when you're going to start the homework. That's the real question. I wanna know. I wanna know when you're gonna actually do the homework. Because we haven't we haven't announced, of course, when the last test and the homework will be due, but we haven't, obviously we're not nowhere close to that point, but I'm gonna see like Strolling and be like, I'm gonna start chapter 10, I'm gonna start chapter 10 tomorrow. And then it's like, it's like being on a diet. I'm gonna start my diet tomorrow. It just at the last minute, just finally got around to starting my diet here. Come on, you guys think I don't know where you're coming from. Let's go. I know how the process works if I wasn't one myself. I encourage you to try and do it earlier so you don't put too much pressure on yourself. But hey, I don't make decisions for you. You're adults. So there you go. That's how it works. All right, ladies and gentlemen, I want to thank everybody for coming on out here to the stream once again here today. Thank you guys so very much. Thank you, everybody. I hope everybody has an absolutely fantastic evening. I hope everybody has a wonderful weekend. And we're going to finish off here again. The next section we're going to do is section 10.3. That will finish off chapter 10. And then we will be moving into chapter 4 right after that. So we're getting close to being done here. So, and very, very close here. So we're working our way slowly but surely, but we'll be done with plenty of time to spare. Also, just to let you guys know here, kind of an announcement here. I probably mentioned this last time, but just a friendly reminder for you guys. I will be going over your homework scores from the last section there, from 5 to 7. I'll also be posting the homework scores and the test scores there on D2L this weekend. So I will have that updated then this weekend. So as something I'm going to be working on. All right. So then you'll have an update of your grade going forward. All right, everybody. Thank you so very much. Enjoy your weekend. All right. Have yourself a great week. Have yourself a great evening, everyone. And as always, everybody, stay safe, stay healthy, but most importantly, stay safe. All right. Have a great one, everyone, and we will see you all later. Take care, everybody. Have a good one. All right, everybody. Take care. Bye. My shot should go just fine, Horace. No problem. Come on, 3 seconds of glory. Take care, my friend. Take care. Have a good one. Bye, everybody.